The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
I was just curious, how important do you think the understanding of computational complexity is, and complexity theory is to the understanding of intelligence in the field of AI?
That's a really, I can't remember anybody asking that question. What common sense questions are complex? That would be a... Yes.
One of the big insights you propose is that the simplest problems that we solve tend to be really complex. I mean, there's different notions of complexity, but in a certain way, let's say computationally, a lot of the simplest things like vision and language acquisition are probably much more complex than a lot of the expertise problems that we usually talk about.
Yeah. Have I shown this slide before? It was published in the Toshiba Journal of Research and Development, because I thought of it at some point when I was in Japan. And
You turn your microphone off, Professor.
I turned it off.
Yes.
I have some hot melt glue, which I could...
We'll try some too.
I'll put my wallet in the other pocket. So this isn't complexity, but I think I talked about this briefly. The idea is, this is one way of classifying problems, and it's a very naive kind of complexity, namely, if you're trying to achieve some situation or reach some goal, then what method should you use? And so this is a cute little table where you just count the number of inputs and how much effect they have. And I didn't bring a pointer either. Oh well, see if it, here's a pointer. So if there are very few causes and each has a small effect, then it's an easy problem. I'm not sure of anything to say about it. If you have a very large number of inputs to a situation and each has a large effect, then it's probably hopeless, because if there are n kinds of inputs and they're all important, then you probably have to exhaustively look at all 2 to the n cases to be sure you haven't missed something. And then here are 8 areas of artificial intelligence for intermediate situations. So that's a kind of complexity but it's not, doesn't say anything about how complex the problem is, but just what kind of context it's in and how many inputs are involved. So anyway, I'd like to see a better table, or if anybody can think of what's another way of classifying artificial intelligence problems. And if you can think of one even dumber than this, I'd be surprised. So, however, if you look at recursive function theory, then every now and then you run into some wonderful discovery, like There's one that's attributed to Friedberg, and who was an undergraduate here. Which says that there are problems that there's some not quite universal Turing machines which still have unsolvable halting problems. And these were constructed by sort of mutilating two universal Turing machines that are talking to each other, and a lot of interesting partial ordering mathematics, which I don't think I could reproduce. So there is these wonderful theories of algorithmic complexity. How many of you have encountered that field? There's a problem that quite a few. My favorite problem is one that I worked on for months and didn't solve. And it was proposed by M.O. Post. In 1923, I think. It's a professor at NYU in New York University in New York. And he had the idea of tag processes. It's called tag because it's one process chasing another one and trying to catch up. And so the idea is you have some string of zeros and ones. And the process that M.O. Post studied, and I wasted a lot of time on, was this. You look at the first symbol in the string, and if it's a 1, then you write 1101 at the end of the string. But you cross off 3 of them. Okay? And then if it's a 0, you write 0, 0, and cross off 3 of them. It's called the tag problem because you're wondering if the front of it is going to catch up to the back. And if there were equal numbers of zeros and ones, then you'd see that sometimes you're adding 4 things, and sometimes you're adding 2, and you're always pulling off 3. So it's sort of crazy. I don't know what got him interested in that in the first place, but oh, this is bad. It's going to be, oh, we're going to get a lot of 1101. So it's getting longer. If I cross out 3 at a time. So if you start with various strings, sometimes it gets pretty long, and then it gets eaten away and disappears, or almost disappears. or it keeps getting longer forever. What's the third case? The third case would be maybe it gets into a loop where it stays the same. If it ever gets back to repeating the same string, then it'll do that forever. So Post asked, is there any string which will grow forever? And a lot of people have simulated this as far as 10 to the 10th steps. And they always grew, except for the ones that stopped pretty soon. So no one knows the answer. Is there an initial string that grows infinite? If you want to waste a summer, try to find either some good theory of that. Anyway, It's not clear what is the significance of that one, but it was discovered partly by me that there were tag systems like this that were universal and could be made to simulate any other machine. The trouble is you have to use a sort of complicated coding to encode the problem for a tag process and decode it again. Anyway, that's an example of a nice computational complexity problem that's still unsolved, and one of you might get some sudden insight and figure out how to, yes?
So you mentioned that you helped prove that this was there were some universal tag systems. I think this is the way that they showed that some 2D cellular automata are universal.
Yes.
By converting it to the tag.
It's pretty similar. I'm trying to remember the one that I proved was universal. It wasn't, it's pretty simple, but it involved just knocking off two each time. But it had, I've forgotten how many symbols it needed. Anyway, I don't think I know any interesting case where computational complexity has actually influenced any work on AI. Have you ever seen any of this? The recursive function theory is a very beautiful branch of mathematics, and it's great fun. It's sort of like geometry in that it starts with almost nothing, and there's quite a lot about it in my old book on computation. There's a bit in Kurzweil's great big book, but I'm not sure what, yeah.
So Watson seems to be like a good system to answer questions. Why is there in AI a division of like what intelligent system is? Because it seems that like the computers that we have and like the, I don't know, the intelligent systems that we have, they're good to solve specific problems. But did we divide intelligence into like fields that we want to solve? Because like as you said, we have like, I don't know, intelligence maybe can be divided in several pieces, and maybe we're not trying to solve like these parts. Like the Turing test says, oh, how we need a machine that wants to imitate the human intelligence or whatever. But the human intelligence itself, it's a bunch of things we can, I don't know, solve
Yes.
different problems. And it seems that there is no division of like the intelligence. Like how, always we are asking like, do we have a system that can achieve human intelligence? But we don't divide this problem. How can we solve this big problem if we don't divide this problem into smaller problems which people can tackle? And then
Well, it's, there are lots of things that we have programs for that people can't solve. So it's, I'm not sure that the word intelligence makes much sense anymore. It's like consciousness. It, you know, maybe at any particular moment you're talking about 5 or 10 or 20 different things. For example, Watson is very good at getting the name of a movie actor from a few clues. But can it do any common sense reasoning? You've been studying it a bit, haven't Henry?
I think it can a little bit, you know, not maybe to the extent that we like, but Eric Mueller, who was, you know, was part of the Watson team, and, you know, he's been working on common sense knowledge, so I think probably does have some capability, but not a whole lot.
It'd be nice to know more about it. I haven't read what they've published, but the trouble is they're not in business for their health.
and why don't we divide like intelligence, like the problem of intelligence into sub-problems and try to tackle them?
Well, there's Howard Gardner with his,
That's what they do, right?
Like they do, I don't know, vision, I don't know.
I mean, that's what like AI researchers do, right? No one's trying to like solve everything at once. People are working on like specific subproblems.
Yeah, but are they integrated?
are which integrated?
I mean, can we integrate these subsystems?
Eventually, hopefully, maybe.
In what sense are people integrated? I mean,
No. Can we integrate these subsystems? Like, okay, somebody's solving like I had a problem with vision.
Well, they would have to know about each other, what the other subsystems can do, so that they could make an estimation that, for example, Watson would be able to decide, oh, this is something that I cannot handle, I have to give it to this other program. So you need to have a good classification system that most of the subsystems need to be able to talk to each other. So I don't know if that was helpful.
yeah, that's what I tried to approximate with these critics, which you have a bunch of systems. I guess we don't know much about how parallel things are in the human brain, but presumably some particular small number of processes are going on at any time, maybe a large number of very trivial processes like, well, I don't know what like, but my picture of the integration in the in human psychology is by having these critics, so that whatever processes are going on, you have other processes that don't understand the ones that are actually doing the work, but have some superficial assessment, like this one is using up half of my sugar, or it's wasted a lot of time and it hasn't solved its quota of problems in the last 5 minutes or 5 seconds, or who knows, 100 milliseconds. In the early work of Newell and Simon, they did lots of experiments with stopwatches and instruments to see how long people took to react to things. And they concluded that for a conscious operation, by conscious I mean something that a person might actually have a word for and mention, and because when they get them solving problems, they train their subjects to keep talking all the time about what they're doing. And so Newell concluded that there were some operations that took about 1/30th of a second, and those were things on the verge of what we might call consciousness, and that there must have been other operations that were 2 or 3 milliseconds that the person couldn't talk about, but he was studying operations which we understand very well, like how you add up columns of numbers and just little arithmetic things, and timing these people with stopwatches for endless periods. And so he found that if you ask somebody to, how much is 8 and 3, the person would say 11. And another time later, he'd ask them, how much is 3 and 8? And he discovered, Newell reports, that it usually takes people noticeably longer in milliseconds to say that 3 and 8 is 11 than to say that 8 and 3 is 11. And he fitted this to data and concluded that when you add 3 and 8, you go 3 and then you count up 24 milliseconds. And he concluded that you're doing addition one at a time in 3 millisecond chunks. Well, that's sort of nutty. But if you do enough experiments, I guess you can prove anything. But where's all this going? I think well, what would Watson need to understand why you can pull something with a string, but you can't push it? And it seems to me if you could find a story in which a famous actor came to a terrible fate because he was pushing a string instead of pulling it, Watson would get that right away, because it would be at the top level of your description of the movie. But the question is, how much progress are they making toward ordinary common sense thinking and reasoning? And I presume, as Henry Lieberman said, if Eric Muller is actually in the middle of that, then they have a first-class AI researcher. And because he did a lot of interesting things before he disappeared from view. Any other? Where else is anything on that scale happening? I bet that's the largest AI program in the world, except maybe there are a couple of secret ones in the classified. It would be nice to believe that there was something like the RAND Corporation actually doing exciting, profound things for the benefit of all of us. But I think I mentioned that I used to hang around there in the middle 1950s, and it was full of wonderful basic research, but then things gradually got classified. Anyway, I'd like to see a few more diagrams like this, just trying to make commonsensical classifications of AI problems, and maybe figuring out where people are there some fairly important basic problems that nobody's working on because they just haven't formulated them. Oops. In a way that they can get people to work on them. Look back at 1970, and here's a program that has a bunch of assumptions about the physical world and understands how to generate sub-goals from goals in various ways and keep track of things. So everyone who's interested in AI should read the PhD theses in the early 70s by Jerry Sussman and Pat Winston and Terry Winograd. And I'd say each of those theses has maybe a dozen lines of research that nobody has followed very far. And because like any other field, AI has sort of run into large-scale global funding fads. And there was a decade in which rule-based systems were virtually the only thing people worked on, and they discovered a certain amount. So lots of rule-based systems are out there in the world doing useful things. They never got to make 3 or 4 levels of criticism in those systems, and so to me that area sort of reached a certain point of economic usefulness, but almost disappeared from the horizon of research. What's that project called? ACT? what's the big rule-based system project that I'm asking Pat Winston there if he.
I'm not sure what you were talking about.
Actar, is that what you're doing?
Yeah.
Yeah, that had a lot of people all over the country sort of participating, and I wonder if anything ever.
Well, it's a descendant of SOAR,
Yeah,
which is the other big production rule system.
that was Newell Simon's.
And they keep refining those and adding this and adding that.
But it doesn't seem to come up to the surface and announce a breakthrough of any sort, or at least I haven't heard of any.
Well, the problem is it's a little hard to tell whether it's a cognitive architecture or a bad programming language.
You mean in order to get it to do something, they have to do something specifically for that, so it didn't just fall
The
out.
programming language is pretty awkward. And because it doesn't actually do anything by itself, it is a programming language.
So is there anything comparable to, are there any big rule-based systems which are not a programming language? They're pretty, after all, programming languages are just fancy things that say, if this, do that.
You can write a rule-based system in Fortran. It's more of a mindset than a set of programs.
Of course, this was written in Lisp, this Winograd thing. I don't know if... One of the things about Lisp, which is potentially important, is that the underlying language is so simple that it's fairly easy to write programs in Lisp that write programs in Lisp. I think it's probably almost impossible to do that in a language like C++, because there's a compiler in the way, and of course you can have an operation saying compile what I just said, but I doubt if one of the features of Terry Winograd's program is that you could tell it to build something, and then the course of building things, it would have to generate, you'd give it a goal and it would generate sub-goals, and it could answer questions about why it did something. So for example, if you built some sort of tower and you asked it, why did you move the green block? Winograd's program could articulate that and say, I had to move it to clean the surface of the large red block so that I could put this other thing on it. And so there you had a program that at one level it's full of rule-based rules, but it only fires up a rule when it has a goal and some knowledge base says a way to achieve that goal is to apply this transformation. Then what Winograd's program did was it kept a record of each of the goals that it had generated and each of the sub-goals that for that goal that it had generated in order to achieve it. And then the great achievement, which was that he got enough English language idioms into the operating system for that if you asked it a question about why it did something, it would actually give the same answer that a person or a child would on the whole. The question to ask is, if they did so much in 1970, what happened in the 40 years since then? And it's quite a mystery. He had 6 graduate students who tried to improve the thing, and they all changed their thesis and advisor at some point. Do you remember? What's the explanation why this never went further? Pat's thesis was in the same year.
I guess I think the explanation is in part that the blocks world presented no serious representation problems. So, moving from the blocks world to some other world, you suddenly have to deal with all kinds of things that the blocks world doesn't have. Like I and you and goals.
It didn't.
Emotional goals, things like that.
Okay, there wasn't anything in the blocks world that had goals.
Right.
Well, there should be something in between. Because you're going all the way to people like Romeo and Juliet. Have you tackled them, or are you in Macbeth?
I'm still in Shakespeare. Mostly Macbeth and Hamlet, which run so parallel.
Of course, you could you could switch to Leonard Bernstein
Probably a good idea. Everybody's seen that, but no one reads Romeo and Juliet.
What was that play called?
West Side Story.
West Side Story. I was born on the West Side, but it didn't have any gangs then. 86th Street. Well,
Since we're on the topic, I noticed you seem to take tragedies. I'm curious what makes a story easier or harder to analyze, and why you picked the ones you did.
Well, why did I pick the ones I did? I mean, Macbeth and Shakespeare stories. Let's see, there's an official answer and the real answer. I'm not sure what the real answer is. I've articulated the official answer so often I'm beginning to believe it. But the official answer is that Shakespeare plots have all the kinds of things you find in any human situation, or any situation that's even the situation between organizations or countries. You get everything. You get greed, you get revenge, you get all kinds of jealousies and threats and all the sorts of things you would want to be able to deal with. So that's the official answer. The real answer is I kind of like those things. And the plots are familiar to me, so I didn't have to go out and But it's really true. If you take any of those Shakespearean plays, they're all about the human condition in various ways. And 2 or 3 of them, you can cover a lot of ground. And I'm presuming that if I can deal with the plot in Macbeth, that I can deal with a lot of stuff.
you probably deal with a lot of other Shakespeare plays.
They run very similar. If you look at the plot in Hamlet and Macbeth, they're almost identical.
I sometimes forget who's who. Yeah. Did they all kill their mother? Or,
Well, they all had. The king was always killed by somebody and killed by somebody else in revenge. And
well,
it's remarkably easy to see analogies between them.
yes, it's been happening in the last months out in real life, almost as though they read the stuff. But now you're allowed to kill them with drones. It's pretty serious. Well, what would you like to see the AI people working on? robot baseball player?
We should finish up soccer first.
Is soccer hard?
It's hard for grown-ups.
How many, I was just talking to Heikki about this. There was a AI researcher named Woodrow Bledsoe who did some of the best early work in visual pattern recognition. And he defeated all of us at ping pong. And one day I asked him, how come you're so good at ping pong? And he said, I don't think I'm any better than any of you, except I look 5 steps ahead. We'll never know if he just made that up. Yeah.
So you asked what AI people should work on. Every time, so I know that classically AI is studied like for linguistic capability, and in recent times I think you and President Winston have been mentioning that other senses should also be taken into account. You know, vision for a long time has been included. But I don't know, every time we talk about this, I always think about what about other senses, like does anyone do anything with olfactory sense? You know, because that can have a big effect on memory, right? You can smell something and then have this memory strongly associated with it. So I think that probably a lot of senses have something interesting, like they probably have something interesting about it, you know, some interesting component of intelligence in them. And I wonder if anyone just has done any of the, you know, if anyone has tried to touch at least on all the senses and what they could possibly do. Or,
it's funny because the olfactory thing I don't know what to say because as far as I know it's just a bunch of chemical detectors, but you could say that about almost anything, I suppose.
Well, the interesting thing to me is they're all coupled. So a smell can remind you of some event that you experienced 30 years ago.
Mm-hmm.
and sometimes a memory can make you, if you remember something, you can kind of experience the smell even though it might not exist, right? Or if you ever had that phenomenon.
Some Microsoft researcher works on the sense of smell in lobsters, and he said that the organs are almost the same as in ours. But of course, you can't say much about a system from the primary detectors. The question is what you do with the stuff.
Well, it seems to me that the important thing about all the senses is that they give us some access, they give us some mechanism that allows us to build up a model of stuff that happens in the world. So if you don't have vision, you substitute touch, and you still get the idea that two solid objects can't intersect each other, and that sort of thing. Things fall.
Yes, I know people who've lost their sense of smell. There's some virus infections that do that. And they miss it a bit, but they're not hugely handicapped. What?
You can get a huge stomachache.
If you eat the wrong thing?
Yeah, because then you'll start eating rotten food.
Mm-hmm. So I guess you make sure that the can isn't under pressure.
Yes, or you make sure that you only buy things from supermarkets that have sell-by dates in them.
Sell by.
So maybe we won't have a sense of smell 100 years from now.
I don't think anybody's built a good smell detector yet.
When like people are trying to create like soccer robots that play soccer, I believe they have problems identifying like the ball if the lights are changing. I think that this is a big problem. Do you believe that's a problem because the algorithms that we have, they are bad, or like it's just like the sensory that we have is bad? For example, Kinetic, they use a different type of sensory to like see people, like to identify people. Maybe it's just a problem with the sensory that we have, and because the algorithms they seem pretty good.
Is the Kinect the one that outlines your posture? Yeah. It's a great gadget. Well, don't get me started on sports. It's just, if you look at the world budget for various activities, it adds up to more than 100%, but how much, what fraction of the gross world product goes into sports and activities like that? That gets back to the, what are we going to do with all the people now that we have 7 billion of them? And I'm pretty sure that the biologists will find ways to treat or slow down most of the degenerative diseases in the next 50 years, say, people should be living for about 200 years. And what will we get them to do? I just gave a lecture to some other people. And there's a scene in 2001 where the pod comes back to the spaceship and it turns the handle on the door and opens the door. And I was very impressed. And the next time I saw Kubrick, I said, how did he get the thing to actually work? And he looked at me as though I were an idiot. And he said, we did that with stop action, and then somebody on the other side of the door turned the doorknob. But I would like to see better robots, and something like this could be, we could make these and throw them up to the moon. And the idea here is, let's make a robot out of very simple modules. So you see there's only two kinds of things here. There are these hinges and these rods, and they have some kind of motor in them. And if we could fabricate them to be pretty reliable and ship up a truckload of them and drop it on the moon, then, and they could each have a solar cell or two, because you don't mind if it takes 10 minutes to move a few inches. Then the idea is if you had enough of these, like 4 or 5, then if any one of them broke, 2 of the others could take it apart and fix it and replace the parts. And for the price of one shuttle flight or 2, we could have robots on the moon for the next 20 years. And what are they doing instead? They're still planning more manned space expeditions at enormous expense, and we may not see them in our lifetimes at the rate NASA is going. As you can see, I don't have a lecture. But okay, what?
Thought and a question. So I was reading Sussman's Hacker, and I noticed that initially the question that was asked, and this is from GPS, Hacker, and NOAA, and Interplan, was they attempted a theory of bugs. But very soon I noticed that the question changed to planning. And then
Planning?
just planning in general, search and planning, and then there was no mention of bugs. There were these ideas of critics and stories, but that died in like 10 years. And it seemed like the focus switched to planning. And the thought I had was maybe it's what question you ask dictates the direction the next few decades are probably going to take. And the question I had was, both in Push's thesis and in Hacker, there's an attempt to build a library of critics. So there are bugs, there are patches, and there's this library which you probably look up. Given a representation, we have this library. Maybe when we hit some threshold for this, especially when we're moving from something like the blocks world to the real world, if that library keeps growing, maybe it's an expensive process. Maybe we want to use that library to create a new representation on the fly. And does that make sense to do?
Well, of course, most representations are worse than the one you have, so it's a great question. How often, where do we get our representations? Do teachers have the idea in grade school or nursery school of what the children are doing? And I'm not sure that we... What do you learn in education school? Is it still conditioned reflexes? Or is there some cognitive psychology? And do modern cognitive psychology people have anything like the representation theories that AI people have? The whole thing seems so muddy to me. I asked the other day how many of you have taken a psychology course. It wasn't many, a few. Do they talk about representations, or are they still in the world of optical illusions and conditioned reflexes and things like that?
They mostly just define words to mean other words, but aren't actually like saying anything.
Well, I don't... That gets back to the... Well, representations. The idea that we all learn about vectors. That's elementary physics nowadays. The idea that vector calculus is only from the time of Willard Gibbs, 1880. When was, can you look up Gibbs? So how come humankind didn't invent a lot of mathematics between the time of Archimedes and Gauss? Gauss is about 1840, and there are a bunch of mathematicians scattered in those periods, but the modern representations in mathematics are, most of them are only about a century or a little more than a century old. So every child invents a lot of new representations, but we don't know much about what they are. And I guess Piaget is the 1930, the first psychologist to try to make effective theories and prove them by experiments on young children, figure out how they represent things. Yeah.
This is Gibbs developed vector analysis from 1880 to 1884.
Isn't that something? Now, what did Descartes do? He got the coordinates.
Yeah. And apparently quaternions existed before then, and some other algebras and calculus.
Yeah, the quaternions were a beautiful dead end. And if Hamilton had invented vectors instead, he might not have been able to handle rotation so well, but all the rest of physics would have been better off. How many of you have ever used a quaternion? For graphics?
Yeah, that's about the only thing useful.
They have amazing property that they only work in 3 dimensions too. So they're no good for relativistic space-time and things like that. It's very strange. Help. Yeah.
There's a study for take a newborn infant and place them on a tabletop for the first time, and they crawl to the edge. They won't fall off. They'll see the edge and crawl back.
That's
Never
terrific.
see the edge before. Do you think this is either some innate representation, some ability to model, and a primitive physics simulation already happening, or do you think this is sort of a hard-coded edge detector?
Or are they just lucky? Well, if you look at a mountain goat, it gets born and drops out, and it starts to walk in about 5 minutes, and then it can follow its mother and knows where to get milk. And when it comes to a crevasse, I get this from Seymour Papert, I haven't seen it myself, but the very first time the baby goat comes to a crevasse, it goes up and around and comes down again. The mother steps across and the fairly newborn baby is following her around.
I don't think they know exactly where to go to get milk.
Maybe they use smell.
I once saw a newborn colt go back and forth between the front legs and the back legs.
Wait,
I once saw a newborn colt go back and forth between the front legs and the back legs, unsure of exactly which one to search for.
mm-hmm. Somebody put this movie of a giraffe being born on the web. Any of you seen that recently? It's just spectacular because the things are so incredibly awkward, but after about 10 minutes, it keeps trying to get up, and after about 10 minutes, it manages to get up and walk, and sort of like juggling. It's really just about to fall over. But anyway, so it looks clear that those things that happen a few minutes after birth, there hasn't been time for much trial and error. But when you think about it, getting food is the most important thing in the universe, and so you could afford to. The system has to put priority on staying alive for the first hour so that you can start to learn after that. So still, it would be nice to know how those circuits work and what is it that's built in. And do the things are your later learning mechanisms mutated copies of the built-in ones at first? And Yes. Is that still there? No. No. How about a 5-minute break? Because I'm running out of voice. There were a lot of discussions. Does anyone want to report on one?
Marvin. So we were talking to Sharad, and we were talking about bugs, and we were talking about, I was describing a system that one of my students, Alex Favor, worked on that tried to understand bugs in web procedures, like you were ordering a book on Amazon, and it used common sense knowledge to say, okay, the parts of a purchase are selection of the book that you want to buy, payment, delivery, and then said, okay, how do we tell if something went wrong? And so then you could break it down and say that if the order got incorrectly, you would have got a receipt. If the delivery happened, then you would have got a FedEx tracking number, and then the system could check these things automatically. So in some sense, that's a little bit like Hacker, having a catalog of different bugs and using common sense knowledge to break it down and understanding if something went wrong. So I think we can have, those are systems that are kind of like end user debugging, so they're debugging without actually having a program to debug. And then we were talking more generally about just the idea of building people's knowledge. There's a lot of this AI stuff generated in the early days, but nobody could have time to explore all the consequences of it, so a lot of things got lost, and certain things got trendy and maybe not always the right things. But still, there's a lot of stuff out there that could be built on, and part of doing interesting research is understanding what's the really important stuff to build on, even if other people don't think it's fashionable, and then you can be innovative by building on that stuff.
It's interesting. Can you think of problem solving as debugging? Because sometimes people think of knowing what to do and planning, but if you think of that Newell and Simon general problem solver, every step is what's the difference between what I want and what I got? And so you could think of the GPS as doing nothing but debugging.
It's actually good at debugging because if you get off track, then it tells you how to repair it.
Well, a higher level one is you might have spent too much time debugging something that was just a minor part. Maybe if you fixed something else, this bug wouldn't have happened anyway. So, is that a theory of problem solving?
Well, I think one important thing about problem solving is keeping track of what depends on what. And so things like truth maintenance systems, that's what they're all about, is trying to keep. So, if you know what depends on what, then you can trace back for debugging.
Are there any systems? Yes, what do companies do when they get complaints? Do they have system?
Send a phone call to India and they tell you they can't help you.
They give you another number to call.
Funny story is I had for one of the, I called the help desk and went to India, and this person picked it up and said, do you have this manual? I said, yes, I do. And they said, could you look at this chapter and this section? I said, okay. And then they said, can you look for your problem in that section? And I said, great. So after like 15 minutes, I ended up fixing it myself. Just didn't know where the manual was. I could have done it myself. So sometimes that happens. that topic, does it make sense to ask how genes represent mistakes? So
Genes?
genes. Is there an idea of if there's an error in mutation or something?
Well, of course, every gene that's selected is selected because the parent managed to solve some problem that the others didn't solve, I suppose. But that's a great question, because I've been complaining that evolution has this big bug, namely it doesn't remember why the losers died. So there are lots of minor bugs in the genetic system. You could call them bugs, but when you have a population of animals and it gets too cold, then some of them die out because they didn't eat enough before it got cold or whatever. And evolution doesn't keep any record of that. But on the other hand, you could say that all the genes you do have are ones that corrected some bug. So in that sense, it remembers how to solve the bugs, but it doesn't remember what the bugs were. So could you make but to make an evolutionary system that kept records of why the losers died wouldn't that take a higher level language or something? Maybe there's no way to evolve such a system.
Maybe you could have a system that reverse engineers based on what did survive, what the mistakes were.
You could have the thing keep 2 copies of the genomes, and when you have children, you have 1 of each. And, oh well, it's too complicated. So when we make artificial evolution, we can probably make the thing millions of times more efficient by keeping a moderate size record of what caused fatalities. Of course, that's what medical records are for, but they don't get back into the genetic system yet.
Doesn't that depend a lot on context? For instance, something may be beneficial during an ice age. But if you institutionalize that, then when you're living in a tropical jungle, it could be to your detriment.
I was just thinking of Ice Age because of what's his name's book. So you'd have to keep copies for millions of years and store all the descriptions of environments and.
Or else you have that same genetic mutation occurring over periods of time, and when it's beneficial, you keep it. And when the circumstances aren't right for it, then it goes away with the idea that it might be able to come back later.
So that's in fact what we do when we have historians in society. And it might not make any sense to try to build it into a low-level genetic system. Just carry books around.
Well, how long will we be able to read those books? Because a language from 1,000 years ago is still, I think, only specialized people can read very, very old Germanic languages, for example. Modern English speakers cannot, for certain. So all of our interpretation of those old texts that more how to avoid people who come at you with spears or swords or whatever have evolved as well. How does that evolution work? The cultural one, or is it an important question?
Well, I think things like the iPad are going to. I was just thinking, my wife was involved with some children who were carrying 30% of their weight in books in elementary school. It's incredible how heavy. They don't even have wheels on their book bag. But with but we could re-engineer the nervous system to have gigabytes of storage. And then evolution could keep lots of records.
I want to know what was being said up there.
Is anyone? Were you talking to Pat?
A little bit about complexity, and also about storytelling, how just some current topics and what his lab is working on. For example, how can you teach if you're going to, people have different models of, so depending on your starting assumptions, something said to you might be taken as propaganda, or it may be taken as something in a sort of less malicious way.
Mm-hmm. What time is his class? I think I should be sitting in on it.
I'm not sure. 6034, I'm not sure.
Yeah.
Monday, Wednesday, Friday, 10 a.m.
It's not so bad.
Fridays usually micro lessons.
Yeah, right.
What?
Lectures are generally Monday and Wednesday, and then Friday there's like a problem solving exam session.
It started out, some Fridays were lectures, and then he's doing less lectures at the end of the semester.
Well, there's not much left, so.
That's the way it always seems, but yeah.
So I missed a lecture last week. Did we talk about maybe interesting past projects for the class?
We didn't.
Maybe can you think of some good ones?
I guess Dustin isn't here tonight. I hate to say it, but the best projects were in the days when you could have an incomplete for a whole year. I think now it's, what is it, the third week of the next term? Yeah, I had some great papers that came a year later, but somebody in the administration decided that incompletes had to be completed. Have you seen any good projects? Because nobody's written them yet for the term projects. I'll try to find some from previous years. Maybe we could get permission to make a book of them.
They also seem to be focused on, there seems to be a preference for some engineering deliverables as well, like some code or program.
Not necessarily. Well, there was a year or two when Bo Morgan was one of the TAs, and he was developing a programming language and wanted to get people to do projects in that language. But wasn't such a good idea because he kept changing the language. What's the best language? Well, if you're going to have which? If you're going to have reflective thinking, then can you do it with the same language at each level? Or because if you don't, what? Oh,
Yiddish.
how many words were there in Latin? Is it a big language?
Depends on how you count.
Mm-hmm.
If you count all the conjugations, that would be 2 orders of magnitude right there.
When I graduated from Harvard, you had a choice of a BA or a BS, and you could get a BA if you had credit in Latin, which I had from grade school. But I never understood a word of it. Hardly. People said, if you learn Latin, then it will be easier for you to learn French and Spanish and Italian and all of those. And after a while, I suddenly realized that if I had learned French or Spanish or Italian, then it would be easier to learn Latin. And I confronted the teachers with that, and they had no good answer. And besides, it should have been Greek, because Latin is full of pretty good stuff, but Greek has Aristotle. Yeah.
I know Latin pretty well, and I find the thing I find it most practically useful for is I'm taking intro to neuroscience, and there's a lot of different neuroscience words. You have to memorize all of them, and they almost all are from Latin. And so I can memorize them based on associations like dorsal. Oh, I know that means back, so I know that's the back direction. And like every word, I only remember because I know what it means. Otherwise, just having to memorize the words would be way more hard.
That reminds me of, I guess it's, my wife, Gloria, is a physician, and she once had a Greek patient, I think. And the patient said, "What's wrong with me?" And she said, "You have gastroenteritis." And he said, "I know that, but what's wrong with me?" And she realized that that was a non-diagnosis that doctors use to make themselves feel that they know what's happening. So have you used it ever? The Latin?
I mean, I use it for what I just described. I also, I don't think things need to have practical value to have utility. I enjoy reading Latin.
Well, what are the best stories? Are there any good plays in ancient Latin?
There are some, yeah. I mostly read poetry or prose.
Poetry. But they don't rhyme, do they? Because the endings are all the same.
Yeah, they generally don't, right?
But it's called
They
poetry.
have a very strict meter.
Okay. A fair amount of the society of mind is in iambic tetrameter. I just found it was easier to think rhythmically sometimes. It's very strange. I'm not sure it does any. If you don't know that there's a meter, it certainly doesn't help understanding anything. But I guess in poetry, if you're skillful, then you're seeing analogies because the emphases are in similar places in different sentences. So you're constructing a network of similarities that beyond the meanings of the words, just from the places where the meter hits. Like this rap is very popular, and that's Alexander Pope. Have any of you looked at any of him? It's all couplets, rhyming couplets, and it's exactly like rap except without the bad music. Oh well.
A little earlier, you speculated about re-engineering the brain to have gigabytes of memory, and to some extent, we already have that with very slow lookup times. So I was wondering if you have any commentary on how we could improve our code tools, computers or otherwise, to help people solve problems and be more intelligent. Do you think these are proceeding in the right direction? Do you think there's other areas of innovation that are lacking?
Well, I think the web is evolving. Things like Google are getting to be quite remarkable. And lately I've been using the Dragon query language. And the things are remarkable. You send, if you ask Dragon a question, it goes to Google and makes up a pretty good query. And just about every time I've tried it in the recent weeks, the answer to, where is the biggest island with a volcano or blah, blah, whatever it is, it comes right up on the first page. It's just, so I suppose that there'll be some very crude thing sometime in the next decades where you put a bunch of sensors over the one of the speech areas in the brain and go right into the web, and maybe at first with words, and after a while you'll get pre-verbal queries, and then there's no telling what'll happen if you have, all sorts of correlated systems with little electrodes in other parts of the brain to give contextual clues.
Would that be the first port that you would suggest installing in the human body?
The first output port?
Yeah.
Or I remember something about the tongue being a great input system. Somebody made a visual system with about 64 or something squared vibrators on the tongue, or electric stimulators, and a person could see an outline of an image. But you have to go have this pad in your mouth all the time. So the question is, can you make sensory inputs or outputs? It's harder to see how to do that. What's amazing is what you can do with your mouth, like eating cherries and saving the pits and not inhaling anything. And so you can do things in your mouth that you can't do with a hand. Of course, 2 hands is better than. But I think getting outputs from the brain to go into memory devices and feeding them back into the brain that's going to become commonplace at some point. But we first have to find out how to do it at all, and then how to implant these things without a big operation and infection risk and all that. Yeah.
People currently, I've heard, get these implants where they get magnets installed. I think
Get what?
Near their ankles. People get magnets installed near their ankles, so they start feeling. They feel slightly when there's a magnetic attraction between the magnets in their legs and something, and so they start developing a sort of magnetic sense. And then apparently people report that even if they get these magnets removed, they still sort of retain the magnetic sense, which is pretty weird.
Sounds weird. Can they tell which way is north?
I don't think so. I think they can tell when they're around objects that the magnets will be attracted to.
You certainly could make a magnetic sensor and put it anywhere in the body connected to a couple of nerves, and then you'd know which way is north all the time. If you remember?
People who made a belt with a compass and it had a bunch of solenoids in it, and it would sort of poke you at whatever part of your waist was pointed north. And after a while, people would sort of no longer notice the poking and just know which way is north.
Oh.
That sort of get incorporated as a sense.
My friend Oliver Selfridge, who died recently, was a pioneer in cybernetics and AI, and he always knew where north was. And it turned out, I traveled around with him some, and whenever he went in a building after a while, and he always knew where north was, but I noticed that he would always go into some office with a window and straighten out the secretary's flowers. He knew the names of all flowers, also in Latin. So apparently he felt uneasy when he was losing track of direction. And he'd go to a window, and before he went in a building, he'd memorize the big features. So.
Does that even work in Stata?
What's that?
In this building,
Did it work in this building? Because I always get lost.
I had the idea of chiseling little arrows pointing north. Are there any vandals among us? It would really be useful.
The Muslims never get lost because they always know which direction Mecca is.
The bug?
The Muslims never get lost because they know always which direction Mecca is.
Oh, right. Yes, I think there should be little arrows pointing north
The first time I
in every room.
visited a Muslim country, I noticed that every time I stayed in a hotel room, there was a little arrow on the ceiling of the hotel room.
Oh, on the ceiling,
On the ceiling, yeah.
where you
there's a little
can't
arrow.
erase it.
Huh? Yeah. And that's where it told you where Mecca was.
We could do that.
Well,
In fact, if we had it point to Mecca instead of north, then nobody could criticize us.
right.
So what's exactly opposite Mecca? What's on the other side of the ocean?
Other side of what?
Yeah, it's in
On the other side of the
Pacific Ocean. Yeah. So I was just thinking that there is a point where mecha is in all directions. And how can you then, oh, okay, maybe I should.
That's not true, because within mecha it's the black cube, right, so you can't be inside.
I think wherever you are, the probability is about 80% that the opposite is ocean. Unless you're in the ocean. Well, it's still 80%. This is a water planet. We could make a little gun that just pops them up there, and it would take them weeks to get maintenance to remove it.
Do you think nobody went to the Watson thing last week?
I haven't heard any reports.
I couldn't make it.
You didn't go?
I wasn't there. Yeah.
Hey, could we get Eric Muller to give us a talk?
That would be cool. Sure.
But I don't know if I wouldn't let him talk too much about it.
Or we could invite him to give a different talk. And then ask questions. It's been 8:59 for a whole minute. There's still time for a question. Nope. Nope. Thank you.